morning one and all. Welcome to the video lecture series on soil mechanics. If you are watching this video for the first time, don't forget to press the subscribe button because very good lectures, very good important videos along with the solutions. For each and every problem we are discussing solution, not only for the specific ones that are important. So don't forget to subscribe the channel and also request your friends and ask your friends to subscribe this channel because very important information which is very useful for the competitive examinations. You need not worry what is happening in the field, but first the preliminary is if you qualify in this examinations only, then only you have the ability to enter into the field. Don't worry what is happening in the ready mix concrete and all the other things, how to crack interview, don't see all other kinds of things. But if you are good at the subject, then you can directly jump into the field. If you can possess good qualification also. It improves your efficiency and also it improves your knowledge also. Preparing for the competitive examinations it is a toughest task, probably for BTech individual. But it is a challenging task for all of us. So coming to the video lecture series, this is lecture number 12 on permeability. In the last lecture we have seen that seepage velocity is equal to discharge velocity upon porosity. Discharge velocity upon porosity, which itself is an important objective question asked many times in GATE and IAS examinations. So we know that the discharge velocity is directly proportional to hydraulic gradient. Thereby we inferred that V is equal to K times I. We inferred that V is equal to some constant into I. This constant is called coefficient of permeability, which has the same unit as that of the velocity unit only. So velocity is directly proportional to hydraulic gradient. That implies V is equal to K times hydraulic gradient. Since hydraulic gradient is a h by n dimension, same dimension, linear dimension to linear dimension ratio, it doesn't have any unit. Hence the unit of coefficient of permeability is same as that of velocity, which itself is another important objective question you can expect in GATE and other PSC examinations. So we can say that V is equal to Ki upon n. This implies you can write it as K by n into I. Can we write like this? Yes, we can write. Hence, another equation we can withdraw is Vs is equal to Kp into n. This K suffix P is called coefficient of percolation. Deep movement into the inside layers of water is called percolation. Water is percolating, means moving down underground. See, the soil path is very complex inside. It cannot be seen through the naked eye. We assume that all the flow is taking place underground very neatly. No, it is not taking place very neatly. See, wherever there is a flow, there is a resistance that is offered to the flow. When you are moving from one place to another place, can you move freely? There are so many breaks in between your movement. Sometimes dog may cause obstruction to you. Sometimes heavy vehicle may cause obstruction to you. Sometimes a lorry may cause obstruction. Sometimes the horn made by an individual with high, high speed and high velocity, high decibels sound, that may also cause obstruction to your movement. In the similar manner, the movement of soil is not very easy, soil water. Every time it undergoes so many obstructions. That what Bernoulli's equation we have described. Head losses will be there definitely. So this Kp is called coefficient of percolation. So always there is a loss during the movement, and also there are so many resistances. Can you move freely to come from your hometown to this place? No, there are so many resistances. By overcoming all the resistances, water flows from one point to another point. In the similar manner, we travel from one area to another area by overcoming so many resistances. There are some people who hurt us, but we have to travel in our lifetime by overcoming all the feelings. In this similar manner, water also while traveling from one point to another point, it overcomes all the resistances. Okay, this is called coefficient of percolation, Kp into n. This seepage velocity, what we call, is directly proportional to this coefficient of percolation. The seepage velocity is directly proportional to this coefficient of percolation. because it depends on the quotient of percolation. Now we see the factors affecting permeability. What are the factors that are affecting the permeability? See, permeability means the ability of water to flow. Water can easily flow. That is permeability, rate of flow. So we can say that the coarse grained soils have higher permeability when compared to fine grained soils. From our earlier discussions, we can easily infer this. Because gravel and other fine sands are very highly permeable compared to fine grained soils like clay. Hence, coarse grained soils, water flows very easily. Sand, water flows very easily. Gravel, water flows very easily. Hence, the permeability of coarse grained soils is more than permeability of fine grained soils. Fine grained soils are less permeable. Why? Because of the presence of adsorbed water. That's what we have discussed. Adsorbed water. Hence, we can say that adsorbed water reduces permeability. Adsorbed water reduces the permeability. Once in the assertion and reason, in IES exam they gave a question. Adsorbed water, assertion, adsorbed water reduces permeability. Reason, because of the presence of absorbed layer in clay, clay soils are less permeable compared to fine sands. Both the assertion and reason are individually correct, and reason is the correct explanation of assertion. We can say that reason is the correct explanation of assertion, since fine grained soils contain adsorbed water, electrochemical forces. We can say that gravel is 1,000,000 times more permeable compared to clay. Always the permeability is expressed in terms of 10 power something, 10 in power minus 2, 10 raised to the power minus 6, like that you express permeability in the field. In the field, as a consulting geotechnical engineer, you express permeability in terms of 10 raised to the power something. So gravel is 1,000,000 times more permeable compared to a clay soil. Okay, permeability of coarse grained soils is more than the permeability of the fine grained soils. Permeability also depends on the particle size of the soil. On the particle size of the soil. Who gave this statement? Allen Hazen's equation. Because it is his statement, Allen Hazen gave on this equation. It is called Allen Hazen's equation for permeability. What he told? Permeability is directly proportional to d10 square of the effective size of the particle. Already we stated that d10 has excellent drainage properties. Hence it was used in filter design also. For slow sand filters and rapid sand filters in environmental engineering, we have seen the effective size of the filter ranges from one value to another value. It's studied in environmental engineering. Why D10 is used there? Because in the field it has excellent drainage properties. Hence, permeability is nothing but ability of water to flow. Wherever there is flow, there is a drainage property associated with the flow. Hence, we can say that permeability is directly proportional to D10 square. That's why I told you D10 has excellent drainage properties. We can say that from this equation K is equal to some constant into D10 square. If the particle size is in centimeter, you can say C is equal to value ranges from 100 to 150. Approximately C value is taken as 100. So K is equal to 100 times D10 square, centimeter per second. Centimeter per second. Since K has unit same that of velocity unit. K has same unit as that of velocity. This itself was an important objective question that was asked so many times in GATE and IES examination. K is equal to some constant into D10 square. You can expect one question. Next, on what factors does the permeability depend? Structure of the soil. Depending on the structure of the soil. Okay. For a flocculated structure, permeability is more compared to dispersed structure. Already we have seen this. What is a flocculated structure? What is a dispersed structure? For a loose sand, permeability is more compared to a dense sand. Why? For a loose sand, all the voids are very loose. Water can easily enter and flow through the voids. For a dense sand, where there is packing, uniform packing, dense sand is like this. Dense sand. Dense, all the voids are very close. Dense sand, that is well compacted sand. Well compacted dense sand has a less permeability obviously compared to a loose sand where void ratio is very very high. Water can easily flow where there is voids, but water cannot flow here. Hence, permeability of loose sand is more when compared to a dense sand. In a similar manner, you can say flocculated structure has more permeability compared to dispersed structure. Okay. Void ratio also influences the permeability. Also, it depends upon the specific surface area. It depends upon the specific surface area, SSA. Already we discussed it. Area upon volume. More the specific surface area, lesser the permeability of the soil. More the specific surface area, lesser the permeability of the soil. In what we have discussed specific surface area, specific surface area is equal to area by volume. Area of a sphere is 4 pi r square. Volume of a sphere is 4/3 pi r cube. It is inversely proportional to size of the particle. Lesser the size of the particle, greater the specific surface area. Greater the specific surface area, lesser the permeability. You can draw several conclusions from this. From this, assertion and reason questions are constructed. This is the area to focus for UPSC civil services or UPSC engineering services or for SSC JEE. You can expect one question from here in this area. You see the relation here. Lesser the size of the particle, greater the specific surface area. Clay has very less size. Size of clay is very very small, less than 0.002 mm. So it has more specific surface area. More the specific surface area, lesser the permeability of the soil. Also, rounded particles has more permeability when compared to angular particle, depending upon the degree of roundness of the particles. Depending on the degree of roundness, you can say that rounded particles has more permeability compared to angular aggregates or angular solids. Also, it depends upon the degree of saturation also. Permeability also depends upon the quotient of permeability also depends upon the degree of saturation of the particle. If the particle is fully saturated, means fully saturated, no air in it, then it is more permeable. Then it is more permeable. Partially saturated soil is less permeable. Why? Because some air is there. Some air violets are there, which are not completely filled with water. Permeability means the ability of water to flow. Water is flowing fully in a fully saturated soil, hence permeability is higher. In fact, there is one important note here to be addressed. One important note you have to consider here. Darcys law. Darcys law is applicable. Darcys law is applicable for fully saturated soils. For fully saturated soils, not for partially saturated soils. Partially saturated soils. Darcys law we have seen that is applicable for fully saturated soils only, not for partially saturated soils. In fact, we have seen Vs, seepage velocity is equal to discharge velocity upon porosity. This equation is valid for fully saturated soils only. For partially saturated soils, this equation becomes, for partially saturated soils, Vs is equal to V upon Ns. Here degree of saturation is considered here. In this equation, if you substitute S is equal to 100%, you can arrive this equation. Vs is equal to V by N. This equation is valid for fully saturated soils. Understand the difference, which will be asked in competitive examinations. This is the area to be focused. For partially saturated soils, seepage velocity is equal to discharge velocity upon N into S, porosity into degree of saturation. For fully saturated soils, Vs is equal to V upon N only. Here N is S is equal to 100%. here. Darcys law is applicable for fully saturated soils, not for partially saturated soils. Hence we have to be careful in this area. It is not simply Vs is equal to V by N that is valid everywhere. Many we do mistakenly. Also in hydrology, porosity is equal to degree of specific yield plus specific retention. We studied this concept in hydrology. But it is true everywhere? No. Ns is equal to Sy plus Sr. Upon keeping S is equal to 100%, we get N is equal to Sy plus Sr. So many examples, so many things. If we go deep into them, there only we can understand them. If we should have feeling for the equation. Otherwise, equation will not have feeling for us. Many people think, sir, we will do one photostat and we do one photocopy and we take photo from your video classes also. We don't write in a notebook. My dear friends, only remember one important point. If you take photo, it will be saved to your gallery and it will be stored in your phone only. But if you write with your own handwriting, it will go to your brain. And you will remember, oh, such and such a time we gave the equation we wrote. Always writing is very important. Storing it will be stored in gallery. And sometimes if the phone GB is not good, then we will delete from the phone also. If the phone space is not enough, what do? We delete all the unnecessary data. By deleting, we delete this also. So don't take photo. It is better always to make a note of all the formulae, all the equations, whatever we are discussing. These are the points, factors affecting the permeability. Also, impurities. Any impurities and other gases, then also they will reduce the ability of water to flow. Also, impurities reduce the permeability. Presence of adsorbed water also reduces the permeability. How much it will reduce? It will reduce void ratio by 10%. That was given by Professor Casgrande. He told that the void ratio will be decreased by 10% in case of adsorbed water. In case of adsorbed water. Later, Carmen Gogini, he was the person, he done a lot of experiments on permeability and he gave his own equation. What is his equation? K is equal to CD square gamma W by mu into E cube by 1 plus E into 1 by K suffix K square. This 1 by K is nothing but Carmen-Gogini constant. His name is Carmen-Gogini. He experimented several things on the permeability, on what factors does the permeability depends, and he gave one equation. In this equation, this K suffix K is called Carmen constant. Carmen constant. In fact, in rapid sand filter and slow sand filter design in environment engineering, you will use his name, Carmen-Gogini. So he told that gamma W by mu are called pore fluid properties. What are gamma W and mu? Pore fluid properties. Generally, these are fluid properties within the pores, within the soil pores. These are the fluid property, unit weight of water and viscosity. We studied in fluid mechanics. This viscosity depends upon the temperature. Viscosity depends on the temperature. Higher the temperature, less viscous the substance. Viscosity varies inversely with temperature. Viscous means resistance to flow. See, oil is the best example to understand the viscosity concept. Oil in winter season, what it will get frozen because of temperatures only. Hence we can say that Viscosity varies inversely with temperature. Permeability is directly proportional to temperature. So this gamma W and mu are called pore fluid properties. So K is directly proportional to unit weight of water and is inversely proportional to viscosity. Less viscous means resistance to flow. Permeability means ability to flow. Always ability to flow is inversely proportional to resistance to flow. Whenever there is higher resistance, there water cannot flow, hence permeability will be less if viscosity is more. If viscosity is more, obviously permeability will be less. These are called pore fluid properties, important. For sands, K1 is to K2 is equal to, for sands, K1 is to K2 is equal to C1 EQ E1 cube by 1 plus E1 into is to C2 E2 cube by 1 plus E2. Approximately they considered C1 and C2 equal in case of sand and they gave ratio E1 cube by 1 plus E1 is to E2 cube by 1 plus E2 for sands. K1 is to K2. And also they gave like this, K1 is to K2 is equal to E1 square is to E2 square. Like that also they gave. And for silts, it depends upon the logarithmic variation. Logarithmic variation. Also, this permeability can be calculated by using Darcys equation. Darcys, father of soil mechanics, gave his own equation to calculate permeability. K is equal to 200 d square into E square. Void ratio and effective size of the particle. 200 d square E square, this is Darcys equation. Also, permeability for clay soil can be conducted by using consolidation test. From the consolidation test data, we can infer permeability of the soil. CV is equal to K upon mv gamma W. This we see in our consolidation chapter. Generally, there will be three different data to calculate permeability. First one is indirect methods. Indirect methods to calculate permeability of the soil. Second one is by field tests, pumping out test and pumping in test from unconfined and confined aquifers. We can calculate permeability. Indirect methods means from these equations like this, consolidation test data, Darcys data, all these are indirect methods to calculate permeability. And the third one is by empirical equations, by empirical methods, empirical approach you can say. By empirical approach also we can calculate this permeability. These are three different methods. By indirect method like consolidation test data, and from the field tests, pumping tests, and also by empirical approach we can calculate the permeability of the soil. For the time being, I am not discussing this field tests in this series of video lectures on soil mechanics. I will discuss in hydrology lectures because it has more connection with hydrology only. Lawden, he is another scientist. Lawden, Professor Lawden, not Laden, Bin Laden, it is Lawden. He is one scientist who gave his equation on permeability. Log K into SS square, specific surface area, is equal to A plus dN. N is porosity, A and B are some constants give. SS refers specific surface area of the particle. From this equation you can calculate permeability. This is for the base 10. This is Lawden's equation. This is one of the equations to calculate the permeability of the soil. So we have seen these are the factors that are affecting the permeability of the soil. Particle size is affecting, type of structure, flocculated or dispersed structure, that is also affecting the permeability of the soil. Presence of adsorbed water also affects the permeability of the soil. Pore fluid property gamma, W and mu also influences the permeability of the soil, and also specific surface area, it also influences the soil permeability. So for coarse grained soils, permeability is done. Permeability is calculated. Quotient of permeability is calculated from constant head permeability test. For coarse grained soils, how do you calculate permeability quotient? Means we calculate the quotient of permeability from the constant head permeability test. What is that test? See here. This is the soil sample. So in this we supply water here through head. So head is maintained constant in this test. Why? Because it is constant head permeability test. Some words give their meaning themselves. Constant head. Here we make the head constant. We make sure that this is called mold, cylindrical mold is called permeameter. You have seen in your laboratory. And we maintain head constant. We make sure that incoming is equal to outgoing, thereby head is maintained constant. Whatever the water we supply, same water we release, and thereby we maintain the head constant. By maintaining the head constant, we will conduct this experiment. Hence it is called constant head permeability test. So here the soil is placed in this cylindrical mold and manometers are inserted. And we maintain the head constant, but it is used for coarse grained soils. The permeability of coarse grained soils is very, very high. Water flows immediately, not in case of fine grained soils. Hence, as the water is flowing with a high velocity, there is a ability to measure the amount of water flow. We can measure the flow by using one jar. We keep and we measure the rate of flow, discharge. But there is no methodology to keep a measuring jar in case of fine grained soils. Why? Because the permeability through the fine grained soils is very, very slow. Drop by drop, drop by drop, drop by drop. Water falls like that. It is very difficult to measure. Hence, there is no measuring device. There is no measuring jar to measure the amount of permeability, to measure the rate of flow. Here, you must observe one thing. Hydraulic gradient is equal to head loss upon change in length. Head loss upon change in length. But here this length means, it doesn't mean the length of the entire soil sample. It does not mean the length of the entire soil sample. It means length of the flow path only. Means how much distance the water has travelled. How much distance the water sample has travelled during its journey. That is the L. It is not the total length. It is the length of flow. Here head difference is measured by using the manometer, delta H. Water rises here and water rises here. Thereby you can get delta H, head difference, from these two manometers. And length means this length of the flow path. It is not total length, cross-sectional length of the soil sample. This mold is called permeameter. 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 It is pronounced like that. Permeameter. The diameter of this permeameter will be given to you by the lab assistant. He will give the value. Thereby you calculate the area. Area is equal to pi by 4 d square. Like that you calculate. So here L refers length of the flow path. That is the point to be noted. So Darcys law is applicable. Why? Darcys law is applicable here. Why? Because the soil is fully saturated. By maintaining the head constant, you are pumping the water. Thereby the soil is fully saturated. Hence, Darcys law Q is equal to Ki is applicable here. It is not partially saturated soil, mind you. It is fully saturated soil. So Q is equal to Ki. Q is equal to Ki. Discharge means volumetric flow rate. Discharge means volumetric flow rate. Volume upon time is equal to K into H by L into A. What is the unit of discharge in fluid mechanics? Meter cube per second. Means in 1 second, how many meter cube of water? That is nothing but discharge. Always from the unit you can refer what is the parameter. In unit time, how much volume of soil water is flowing through the soil sample? In unit time, how much volume of water is flowing through the soil sample? You see the beauty of the equation. So the equation describes you what is it. In unit time, here unit time does not infer time is equal to 1. Unit means it can be any quantity. Time can be 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 10 seconds, 60 seconds. In unit time, how much water is collected in this measuring jar? That is discharge. Discharge means volumetric flow rate. Why the term rate is described? Because with time, anything is rate. So volume by time is equal to Kh by L into A. Okay, we will leave, no problem. Thereby we can calculate the quotient of permeability from this equation. So this is the story regarding the coarse grained soils. Always there is a specific measuring device to measure because the permeability rate is very more. We will also describe fine grained soils and end this session. Don't worry. For fine grained soils, falling head test is used to determine the quotient of permeability.